Manufacturing and industrial environments provide their own unique challenges for wireless communications. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. This is where we come to discuss those challenges, share ideas, and help one another out. My name is Scott McNeil, and welcome to the Industrial Wi-Fi Shop. Welcome back, everybody, to the Industrial Wi-Fi Shop. My name is Scott McNeil. Today is going to be a lot of fun. We are talking with Jeremy Baker, and he is, a whiz with all things robots and cranes and rides. Oh my. Jeremy, why don't you take a second and tell us a little bit about who you are and what you do and who you work for?
Thank you, Scott, and thank you for having me. My name is Jeremy Baker. I am a consulting network engineer for Prism Systems, which is a systems integrator based out of Mobile, Alabama. We have offices internationally, as well as like a large presence in Orlando for our entertainment customers. And I am what we call internally, primarily on the commercial wireless side. We have as well entertainment provisions, and the main thing that we handle is typically what we call high availability wireless, so deterministic safety, and we work with a number of vendors, pretty much agnostic, but we got some that we work pretty intimately with. And I've been with the company about 10 years.
Well, that's awesome, man. What's your favorite aspect project wise?
My little pocket is a lot of short and sweet trips. I like getting out of the 2 to 3 month deployments. I got young kids, so it's fun being able to get on a plane, get in and get out.
Yeah, I do enjoy the aspect of a lot of my projects being OT network and infrastructure and wireless. My projects are much shorter duration than all of our controls guys who could be on a same project for months or even a year or sometimes longer.
Yeah. The bummer about it is that you don't really get to see any of the fun stuff in cities, or you're flying to a nice city and then you're driving 2 hours to a small manufacturing area, and the pickings are slim.
Right, because you're only there 3, 4, 5 days as opposed to several months, so you don't get to really see the area. But be that as it may, let's kind of tie some things into our last episode. When you're looking at a new mobility project, be it manufacturing, be it entertainment, or be it dirty industrial, what are some of the things that you look at during the assessment process for key things that you need to be aware of when you're going in?
Well, so I would say that this might be jumping the shark, but one of the big things up front is just trying to get site drawings and stuff. So as you go, you can kind of generate living documents up front. And then it's, from there, if it's entertainment, it is, what are the constraints that are physical environment? Are there frequency constraints that you have, especially entertainment? Is there a whole bunch of stuff already in place? Can you get frequency from IT? Do they already have dedicated frequency for automation? Sometimes it's even, what's the infrastructure that they do have? And then one of the big ones is kind of timeline. What are they looking for?
So a big thing that you're looking for is pre-existing wireless, be it structured 802.11 or various other protocols, and then what the kind of RF looks like on top of getting site drawings, right?
Yeah, you want to paint a picture for as best as you can for what's there, because that's, in the quoting phase or the initial discussion phase, you really don't have a lot of information, and you don't want to turn something over to a customer and say, hey, we need 5 times what we actually need, because we just don't know. So it's really kind of asking the questions up front, and then, do they, is there a specific hardware that you can right size for the application?
Yeah, that's a big thing, because the resulting sticker shock can kill a project pretty quick if you don't have all the right information up front. I've been there and done that, so I totally get that. So when you're looking at these projects, let's look at, say, some more manufacturing kind of AVG type applications. What kind of latency are you seeing that these guys are looking for in order for a successful robot deployment, shuffling around the warehouse floors, whether they be going and just shelving stock or getting things for distribution?
So for like the AGVs and the AGCs, if you're looking at just purely like a warehouse application, a lot of times those can be, 3 to 5 seconds. They don't, that they need before they really have to check in with their server because the safety is on the vehicle. So, obviously you want to beat that and beat it by a lot. But if the AGV gets lost and it disconnects or it's not able to reassociate, its default mode is just stop, don't do anything. It doesn't want to run anybody over. It doesn't want to damage infrastructure or anything like that. So you get an AGV that loses communication and stops, and then all of a sudden you've got a whole process bottleneck. And in warehousing, it's inconvenient because it'll tie up a manufacturer or it'll tie up a maintenance person typically to go like move it and help it reassociate it. In automotive manufacturing or steel or any of those kind of processes, you're talking about thousands, hundreds of thousands of dollars of downtime if you stop a line for a long period of time. So it's pretty important to just make sure that the communication is layer 2, low latency, limit retransmissions, don't get fancy.
So do you find yourself doing a lot of like broadcast optimization, multicast optimization, easy for me to say, right? Within the actual configurations wireless wise?
So sometimes it's typically in the initial phase to just get it working. You want to pull as few levers as possible. But yeah, you'll try to see if you can get as many clear channels as you can so you can minimize the CCI. The contention domain is what's really important there. And then from there, sometimes you do have to do things like quality of service mapping. That's kind of more on the entertainment side, or even kind of best effort or like adjusting fundamentally like how it does the packet transfer. Does it hold on to a couple of packets and buffer it, or does it just send one or two little things at a time? And so typically we just try to get everything out. And sometimes, a vehicle might have video or something like that exported off of that, and that's got to be a lower priority than the actual safety traffic. So it's kind of segmenting that stuff so it comes out in the right order with the right priority.
That being said, I'm curious, do you use a lot of fast transitioning, fast roaming? What is it, K and R?
So in 802.11, not really. Sometimes customers will want to implement that stuff, but really it's in a typical AGV deployment. What we found is just limiting, almost like restricting it to run like an 802.11a, like just keeping it from trying to send a bunch of stuff as fast as it can, but just reliably transmitting it and not holding on to packets. But some
like channel restriction and things like that. So it's not scanning every channel; it's only scanning 2 or 3
and
channels.
Typically, like you'll get maybe 4 or 5 I mean, if you're lucky, you'll get 4 or 5 channels in a site that are dedicated. So then you can reduce the pool of channels that the radio will scan. And a lot of the commercial side for like fork trucks and clamps and carts, you will play around with like the roaming threshold or delta or whatever it is. And sometimes, sites will already have these going, and they'll, somebody that doesn't really do this very often might opt to say, oh, we want this to roam as soon as the signal looks bad. And then you end up with a vehicle ping-ponging back and forth between access points. And then you start getting a lot of retransmissions because you get all the overhead packets of the roam. So you'll see that as kind of a problem more on the 802.11 side.
Right. So I'm assuming at that point, you're really not using anything in 2.4. It's all primarily 5 gig.
No, it's 2.4 is for the birds. I don't know if that's the right way to say it, but yeah, typically it's like we try to just steer away from 2.4 and let that be like an IoT thing.
Interesting. Yeah, that's exactly what's eating up that 2.4 space these days is IoT sensor packages, and then things like ISA 100 and wireless HART. They don't seem to want to go away from 2.4, and then they use spread spectrums. They pollute the whole thing anyway. It's interesting. Have you guys done anything?
Yeah, I've seen some of your spectrum analysis.
I love me some spec and have you guys done anything in that'll get me sidetracked and start a whole nother story? Have you guys done anything in 6 gigahertz now that it's open and available?
We are looking into that because, as the tri-band radios and stuff are coming out, we've got customers that the infrastructure is being installed and they're asking for it. And so we're trying to vet some of the clients, but there hasn't really been any of the ones that we would consider like an industrial rated one. So if anybody listens to this has a good one, please message me. But yeah, so we're looking at them, and like a lot of them, it's like you message the manufacturer and they're still kind of waiting on FCC approval and stuff to be able to operate in that range. But it's definitely like it's on the horizon, just like private cellular and stuff.
I gotcha.
Which apparently has been very successful throughout. too. But yeah, so it's not yet, but it's on the to-do list, actually, more so than the radar.
Well, when we're looking at these kind of deployments, moving away from AVGs and things running around the floor, what about something a little more dirty, something like large heavy equipment roaming, either like radial cranes, gantry cranes, or other heavy equipment?
Oh yeah, I mean, like like an overhead crane, like in a steel mill or a warehouse, we do a ton of those, and it's a lot of times that kind of ends up being, what's the budget appetite. Very reliable. If you run them on our coax, you can put a segment all the way down. You always have solid contact with the radio. And what we've kind of moved to is using some of the kind of like the rail application type antennas that are bidirectional on the cranes themselves. If the crane bay is sufficiently long, we can like end feed with a patch antenna, so that way you're always going towards, one signal is always strengthened as the other weakens. And then using similar, like the infrastructure side, bidirectionals in the mid bay, so that way if you've got kind of two cranes contending, then you reduce the shadowing of you don't get a crane in front of the other one. Then for kind of radial stuff, it's like sometimes that you have to get creative if it's something that like rotates, to just try to make sure that you've got like line of sight for something. And even sometimes it's
Right.
we've got some carousel projects right now that are coax, and it's the client or the omnidirectional antenna for the R coax is on the ground for some of the carousels because they're linked. And then on the carousel itself, the R coax is mounted around it. So that way it's out of the way for maintenance people stepping over it and possibly damaging it. So there's all kinds of stuff like that.
What kind of range are you getting out of the Arcoax just in general? Most of what I've seen and read has been all near field, but I haven't really heard of anything that.
It depends, right? Because in the lab, when you're testing, you can get, we can connect to that stuff like 10 or 15 feet out, but you really would not want to do it. Then some of the specific antennas say, you want to be within an inch or 2 inches of it. We've got applications where we put it in and it's 10 to 12 inches from it, and it's fine as it runs. And then on the opposite side of that too is dependent on the frequency, the length that you can run the coax before you have to put another access point. And so they'll say like you can run 90 meters, but really like in practice, you want to go a little bit less than that. And then on top of that, you're probably putting fixed attenuators or software defined attenuators on that to kind of tamp it down. But yeah, you'd have to test it. And if you had clean channels, you could probably get a couple of feet away from it. But at that point, it'd be kind of a science experiment.
And that's not the kind of test you want to run for reliability in the middle of a project, I'm assuming.
Yeah. No.
I did one large mobility deployment, but it was for a set of stacker reclaimers in a wood yard. The latency requirements weren't crazy. I think the IO check-in was every 75 to 100 milliseconds. So the latency aspect of it wasn't crazy. And the fact that the stacker and reclaimer booms moved really slowly, it's not like I was having to worry about high-speed rail. But failover between base radios was very, very important. And the redundancy was very, very important, so that everything could run regardless if one of those bases went down. Because it's a wood yard; it constantly has an influx of wood chips and an outgoing flux of wood chips, and it's a constant process. And you said it before, anytime you stop the manufacturing process, be it discrete, be it batch, be it process, actual engineering, that's money not being made, and people start getting upset.
Yeah, and a lot of times just buying the hardware and putting it in, the ROI is like a week. It's not even that much time. So it's kind of being an evangelist for the technology or the right way to implement or fix something. And I think we'll probably get into this a little bit later, but that's something that when we come to customers, sometimes you're talking to the maintenance supervisor or the kind of site contact that handles the stuff that may not be fully proficient in the wireless technology, or the know enough to be dangerous, very reliable, always there person. And so you kind of have to be able to give them the tools to be able to go up the chain of command for their people to basically kind of say, hey, here's what we're seeing. Here's a way that we can resolve this. So yeah, it's the downtime is pretty intense. And you were showing me that, that installation, and it's pretty tricky because it's like, where you mounted those radios and stuff, it's like, how do you get power out there? What gauge wire do you need? You put something on there, it may not even be a wireless issue. It might be that the ground wire runs through the drip pan of the air conditioner they installed.
Right.
And the power browns out just enough that the radio stops transmitting, but it doesn't give a fault. And so, there's all kinds of stuff that you run into.
Well, and then on top of that, the actual vibration of the equipment. It's large, heavy equipment that looks like a transformer, and you're waiting for an Autobot to come folding out, but it's just vibrating as it goes along its track, trying to do its job.
Mm-hmm.
It's
and you don't want to use SMA connectors in that situation for sure.
Absolutely not. No, that's M12X coded all the way. What is one of your favorite robot installations that you've done over the past 10 years that you've been doing this?
Well, I mean, really my favorite project of all time was on a farm, getting to ride putting a boom lift up and mounting some radios and doing a point-to-point backhaul. And then I got to ride a side-by-side around gathering data. But a fun robot one is, I would say, probably the Kelly Slater wave pool would be a really good example of that. And that kind of touches on some of the stuff that you said. It was like one of my first projects with Prism, and it was a Siemens deployment, and they had redundant connections from their winch house out to this, they call it a bogey, but it's basically just a big fin that drags in the water 2 direction, creates like a 2,000 meter long consistent wave.
I'll put a link to the YouTube video in the.
Yeah, it's pretty rad. But that has 2 frequencies, like a point-to-point link, and then we're using not the proprietary PRP protocol in that, but just a redundancy box that basically splits a packet as an A and a B packet, and then feeds that into a radio A and B. And then on the opposite side of that, once it comes through the radio, it gathers it back together and then sends it out. And then it doesn't know that. And Scott, I don't know if you've messed with too much on the wired side PRP, but that's got some challenges too. That stuff.
Amazing what it goes into to make the perfect wave.
Yeah. I was like, I'm not really, I'm more built like a buoy than a surfer. So I don't think they'd let me ride a jet ski out there with my air magnet.
No.
That'd be pretty fun.
No.
But yeah, that's kind of the coolest thing, because it's, you go to this little like configuration shop, and that's you're setting this stuff up, and you got 2 high gain point to point antennas sitting on a cabinet right next to each other. And then you don't really know that you probably don't need to be beaming that energy into you at first. And then, then it's like, hey, well, these antennas even reach this distance. So
you said these were Siemens radios?
Yeah, these were Siemens. And then they're like 23 dB patch antennas. So we had to kind of pull a bookshelf out, or one of those like wire basket stands, and mount one of the antennas on it, and then actually use the power inverter from the rental car, and then put the other antenna in my car and drove it, as far as I could get away with point to point, and then running a ping tool across it just to make sure that it worked. So like the upfront stuff is kind of fun, or you running safety over it, you got to be able to get a signal across there. And you were asking kind of about the safety timeout. And a lot of times, like entertainment, if you have a passenger or something on there, the safety is typically on vehicle, and then the check-in is every 30 milliseconds. This is kind of average. Every 30 milliseconds, it's sending an update, or it's sending a communication there. And the tolerance is 100 milliseconds, right? So if you don't hear from it in 100 milliseconds, the ride shuts down. And then the wave pool, they jet ski you off of there or whatever, right? Or you just swim to the side. But in like a person carrying vehicle, it's an hour to reset the ride. You have to evacuate everybody off of it, put the vehicles back in staging, requeue, redeploy. So it's a very big deal if you drop something. So commercial, if you got, an AGV in a warehouse, 2 to 3 seconds is, that's like all the time in the world. So it's a little bit different. And those short, latency requirements, that's like an overhead car carrier and an automotive, stuff like that. If those lose track, those will shut down too, because they don't, in that situation, they don't want to necessarily like misalign the encoder reading or something like that when they try to marry a body and a chassis. Things can get damaged. Or do we know if the hook actually turned to release the body from it? And that's really a big deal when you flip a car body off a carrier or something on a line.
Yeah, I would imagine so. Well, that's a great segue. And I had a question I was curious about. When you're doing wireless ride controls or something like the Kelly Slater wave pool, are you working directly with the controls engineers to get requirements from them?
Oh yeah. So in something like that, I mean, you don't just like Wild West, that kind of stuff. I mean, a lot of times that is before they're even building the ride. You have
You've already had like a pre-engagement to start
you
this.
you've got like a functional, like an FDS, a functional design spec from the customer, and then there's probably 100 meetings before it goes forward. And so you'll have a preliminary design review, and then you kind of talk through stuff, and then at some point in time you say, okay, it's, this is Beckhoff controller or Siemens PLC, or whatever it is, and then you build a benchtop test and just say, hey, I showed you a little bit earlier, you might not even put antennas, right? You might just run it through variable attenuators and then just wire the radios together and just say, will this radio handle the protocol in a lab setting in the time frame we're expecting? Because sometimes it's not typical manufacturing. You don't really get any of that weird stuff. But when you get into the entertainment side, you might be sending safety, but you might also be sending like a very proprietary audio visual packet across there. And so it's like, can this handle this? Is it licensed for Profinet? Can it handle a Profinet packet? Can it handle I don't know if I can say the name of the people, but generic audio encoding thing, across there. So it's even, is this able to handle this? And so then you kind of figure out, okay, in an 802.11 radio, do I have the MTU size correct? Can I do that? Are we missing packets? And so you run 2 weeks of tests on that stuff before you even really start. I mean, it's concurrent, but then you start kind of picking out site locations and antenna types. And we've got some vendors that we work with from an antenna standpoint, and so we'll kind of start talking to them and say, hey, what do you think is going to work in this situation? And so it's really, it's like a big group project, but people actually do their own work that they're supposed to.
So really the whole proof of concept process is incredibly important to all these projects, especially when you're trying to tie in wireless IO along the same signal path as audio visual response data. That's interesting.
Mm-hmm.
That's an interesting conglomeration of what you're trying to shoot across these radios.
Yeah, and to kind of put some meat on the bone of that is, you have say just like a caravan of vehicles, parade going through an area, and you have 15 access points along the route, and each vehicle is going to have a radio on it to talk, and you can get away with just a single band, like in the Cisco Curve or what was Fluid Mesh. That's a little bit different of a story than when you have something like, like an enclosed dark ride at an entertainment customer, and then you have these vehicles that are trackless that can go anywhere, and you've got 30 vehicles running in a small space, and you have 50 or 60 access points in a small warehouse, and it's very RF dense. And then you have sometimes one frequency is almost never existent there, right? It's then becomes 2 frequencies, 3 frequencies, 4 frequencies. Okay, well, crap. We've got to split the fleet, so half the radios run on AB, half the radios run on CD. So then you kind of go back to like in the Kelly Slater situation, which some of their stuff runs on Curve now too, but it's you're not just using like a PRP system at that point. Now there's also a thing called MPO, which is a similar thing, but it's like the first across the finish line is all that matters in those kind of situations. So it's like you have a bunch of kind of duplicate transmissions, but really you just need the packet to get there as quickly as possible. So it can get really messy really quick, depending on what it is. So you wouldn't want to just throw a dart at a board and say, we need 50 radios and we'll just figure out where it is. It's kind of, you figure out fleet size, you figure out space constraints. In entertainment, you figure out if you can even put a radio in the right place at a certain point. Can they cover it up with a fiberglass rock or, whatever it is, so the guest doesn't see it?
That's interesting. I was just with my family at Disney for a week, and we were going through several rides like Mickey's Runaway Railroad and Ratatouille. And I specifically, when I go into these now, I'm trying to find anything that's giving it away. So you guys have become masters of disguising your work, because I have only spotted one radio within those. I wasn't fast enough to get a picture.
Well, that's all for, on the entertainment side, like all that stuff is like Ride Show and their creative departments kind of say, you say, I want something in this general area. And then they say, okay, we could probably put it here. Or we've got an overseas application where it's, where it's like a water vehicle that rides around and trying to like go through, there's like a window that we can use. So it's like, okay, well, they can make like a fake painted wood cover for the window. So you got an antenna going behind it and you're like, oh, great. But, thanks for the attenuation. This is already going like so far. But yeah, it's wherever you're at, the challenges kind of multiply, or it's kind of like a chameleon, it just takes on, you end up taking on the flavor of wherever you're at.
So you were mentioning wireless safety in general, and that was something we were kind of discussing pregame. Can you define for me what you mean by deterministic or high availability wireless safety?
Yeah, so deterministic would be, there's like Siemens would call it industrial point control function, but that basically means that PLC or controllers in general, they basically just run through a series of ladder, and sometimes it's not ladder now. It goes rung one, check, 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 and then all that stuff gets written to kind of a function block that then, and the IO updates that. And so every 32 milliseconds, that PLC runs through that code, checks all those things, and updates statuses. And so then maybe an interlock condition changes. Maybe it's clear for a vehicle to go, or maybe something needs to stop, or a pump needs to turn on. What's meant by deterministic means that every 32 milliseconds, that PLC cycle time, the client needs to be able to have access to communicate across the medium. So in that, there are things that are time slice, or so that will be kind of more on the Siemens side, or something like a maybe like a Cisco curb would be, there's no roaming and stuff, but it's the only stuff typically going across those is the safety stuff where you can help it. And sometimes you might put like an 802.11 sub WLAN in place to kind of offload some of that stuff for maintenance purposes, or just being able to kind of see what's going on a vehicle. And so similarly, like high availability, that just means that you need to always have communication. So, sub curb says sub millisecond roaming, 3 to 5 milliseconds. But it's really kind of, instead of if you are on a laptop in a warehouse and you need to check an email, if you have to wait 15 seconds for that to populate, that's not a big deal. If you're running a forklift through an area where there's traffic or something, you need to know instantaneously that thing's going to stop, or you could damage something if the conditions change, or if the vehicle loses track of where it is because a human ran a forklift into one of the anchors on the wall. So it basically, deterministic is probably the most accurate word to use. And that just means that I know that I'm going to get a chance to speak. I've got the talking stick at least once per cycle.
Right. That is interesting. I have not done personally any wireless safety, so I'm always curious to hear how that works. And something I was thinking about earlier is a big part of what we do is then educating the end client on how this works, so that they can at least do triage support before trying to pull us back in. And all of this is great information, because it's in a roundabout way we're letting everybody know some of these important concepts and aspects of what goes on with what we do. With that being said, what are some of the things that you think in general OT and controls guys need to know about wireless safety, either how it works or just things that you think that they need to be aware of?
Well, I would say maybe before you talk about wireless safety, kind of general knowledge, like if you're an IT or OT, IT controls, any of those kind of people, but you are touching like an OT wireless situation, be aware, what's the hardware that you have? How is it powered? What are some of the troubleshooting capabilities that are there? And, a lot of times when we go to a customer site, it's always, let's make it, screenshots, write a little document, just have an idea how to do that stuff. And then in a lot of these, big thing is have kind of pre-provisioned spares for that kind of stuff, because when something goes out, it's not so much, I don't want to say set it and forget it, but it really is like, so you stack the rocks in a certain way, you get them nicely balanced, and then it's like, do not touch anything, right?
Absolutely. And honestly, the set it and forget it really is what you're doing. So
It's what you're hoping for.
you're what you're hoping for, and that's a fairly accurate description.
And then when you start seeing stuff, that's where it's kind of there's everybody's got kind of a different tool. A good example I would say is that I'm not going to name any names of any work group bridges or client radios or infrastructure or anything that we run into, but some of the things, it's like we'll talk to the manufacturers and say, hey, what do you have to be able to troubleshoot stuff? And there, you've probably seen this a bunch, right? It's like, this is a nice little wireless client to go in a box and it's not going to move. But once you get stuff moving, you've got weird situations, and it can be costly to pull somebody off a project and send them to site to gather data. So an example of this would be like, if you have something like a Siemens radio, they have a built-in signal recorder that's in there. And so it's, you try to educate people while you're on site and say, hey, the first thing I'm going to ask you to do when you call me anyway is if you have the vehicle dropping out as it goes through this doorway, do you know if anything changed? But I'm going to ask you to start that signal recorder and run that vehicle through there and see if you can capture that event, and then look at it. And then you get the MAC address of the BSS ID, and you can say, okay, it's not talking to this radio that it usually talks to, because, we haven't even touched on this yet, right? But there's like, the site analysis, there's, their pre-deployment survey, just like an IT person, right? Pre-deployment survey, post-installation validation. So you should know this access points here, this access points here. Is it a standard? If we can get a static channel plan, sometimes that's nice. A lot of times that's not necessarily possible. Then you can kind of try and catch some of those areas and see, okay, physical hardware, things move. Definitely wireless safety. It's a lot of stuff. It ends up being layer one, and that when you do have problems, and it's did the connector wear out? Did it get reseated properly? Did somebody accidentally tug a wire out? And then kind of on the control side, it really definitely, for like wireless safety projects, your PLC guy or your controls person, or gal, whoever it is, that person, have them understand that, if you tell me that the spec is 64 millisecond cycle time or 32 millisecond cycle time, make sure that that's there. And a big one, this is like low hanging fruit. And this is like one of the ones that you always see is like that controls guys like, I want this data instantaneously. So they'll use like an RPI in their, in their program of like 1 milliseconds or 0 milliseconds. So it's just constantly hammering the IO. And it's like, really, that might need to be 10 milliseconds, or it's like once per cycle, it just needs to pull that stuff and get that information and have it updated. And so we'll see that. And it's like, well, it's timing out, and you're basically just trying to blast this stuff over the wireless, and it just can't handle it. Like, it doesn't have the bandwidth to instantaneously update. So that's definitely one. It's like, we'll see stuff like that. So kind of having the people that are adjacent to the wireless kind of understand the limitations of a wireless system. And then even like the wireless people, having them understand how to get into a controls program and check the bits, or like trace a command, or see any of those kind of things and see what's going on with that. So cross training is really.
That's a great segue, actually, because I was going to ask you, for wireless people in general, what are some of the things that they need to be aware of when heading into a project like this, especially if they haven't done something as specific as that before?
Yeah. Well, I mean, I don't know how often you've gone to a site, and then there's also like the low voltage vendor. We don't do like physical installation. We'll come supervise, we'll do those kinds of things, but we, typically like we'll handhold a subcontractor or something like that. But you get these guys that have done, very sharp people, right? That have done, a ton of enterprise deployments. And then they come into these places and they just don't really have a good idea about some of that stuff. So I would say
I have a laundry list of stories that I am not going to get into on this show because it would be completely inappropriate. Yeah. But yes, I know what you're talking about.
But I think like wireless people coming into those situations, it's a similar situation, right? It's like you may not even, this may be your first adventure in OT. When you land, go to Home Depot and buy yourself a bucket so you got somewhere to sit.
You don't know how good that advice really is.
But no, seriously, it's find out if you're going to be touching systems that have controls, like suck up to the AGV guys and find out how they jog the vehicle, get them to show you how to do that, because you might not want to wait an hour for them to come move a vehicle around for you to test some stuff on like a lunch break or something. Find out, if it's TIA portal or if it's, RS Logics or whatever, like look over those people's shoulder if they'll let you, and just get a feel for like what they're looking at and like how their system functions. Because if you do a good job, you're going to be working with those people on other projects. And it's, it's good to know the topology of how something talks, or like kind of where to look to see, okay, this is, this is like a lost comms error. And so sometimes even in gypsum, right, where they make sheetrock, it's a dusty environment. And so you'll get called in and everything's the wireless's problem. And then you get there and it says, okay, there's a sensor error on the vehicle. And then you start looking around and you go, oh, there's this sick prox sensor at the bottom, and it's dusty. Let's wipe it. And then the error's cleared up. And then the maintenance people aren't wiping this every shift like they're supposed to, because it's hard. Those things are running around. It's hard to get to them. And just like us, they got 100 things on their desk to do.
Well, I think that's one of the things that we OT wireless guys and enterprise wireless guys have in common. And that is 70 to 80% of the time defending the fact that it's
our
not a
fault.
wireless problem. It's something else. Like you say, it's not a clean sensor, or it's DNS, or it's authentication issues on the back end. There's a lot of different things that can go wrong, but it's always immediately it's a wireless problem.
Yeah. And here's another one too. Like if you're for like wireless people coming into these, if you're working with a team, do your best to get buy-in from the IT side, because I can't tell you how many times we've gone to do like a 1-day wireless audit, and we could do a little bit of test and adjust and say, oh, you got a little bit of low power here. And it's like, it's a real bummer sending a customer a report and saying, well, you've got dead zone here, and we could have adjusted the power and seen if we fix this, but guys in your NOC didn't answer the phone, or like, and sometimes you can't make changes mid shift and stuff like that. But, it's like, try to get buy-in from those people, because if you can go to site, like unfortunately, I'm billing you for the full day that I'm there. And if I'm sitting in a conference room doing nothing, that's the thing that's really frustrating, because it's like, I want to give you a good experience. I want you to have a functioning system, and I would rather take care of stuff up front when you can, then send you a report, and then you have to fly somebody back out to validate it. And it's,
your whole point of getting buy-in with IT is something I talk about all the time, because not only is it for when you have to, you need changes made, or you notice different things, but it's the coexistence of everything that you're getting ready to put in is going to have to live in harmony with all the stuff that IT already has in place for their business case.
Yeah.
So having that harmonious relationship with IT services and OT services sure does make the job easy.
And two, like, I'm thinking of a metal manufacturer that we've been at, that we put a curb system in, and you kind of talk to the IT people and you say, in some instances like in that, you need a dedicated frequency, at least, for a single band application, sometimes multiples, right? And if you have adjacent bays with cranes, you want them on different frequencies so they don't interfere with each other. But it's like, that stuff doesn't put out a beacon frame. It doesn't let any, you're going to see it in a spectrum analysis, but you're not going to see it in something like an air magnet. And so that kind of comes back to what, the person that's on site, that's on OT, when you're getting one of these systems onboarded, don't be the person that is looking at your phone trying to find a date for the night. I've had that happen. When we're saying, here's the way that you can check this, here's the way that you can look at this, these are the tools that are available. I'll put them on a thumb drive. I'll transmit them to you. Here's where you can download it from the website. Familiarize yourself with this. I'm going to give you a brief write-up on how to do this anyway. But if you call me, it'd be much better if you called me and said, hey, I was measuring this stuff and I saw this, and this, and I can answer a 5-minute question to you and save you a site visit, or, all that kind of stuff. And similarly too, and sometimes too, it's like pre-provision, I cannot harp on this enough, but like pre-provision spares, it's like, this stuff is not,
absolutely,
it's not like
a 5-minute conversation that saves a $5,000 bill.
Yeah. Well, and stuff like, on the enterprise system, right? It's like, a lot of times, like, you can put something in like adjust a Mac, and typically you probably have like, somebody can move to a conference room if the AP over their desk goes out. But if you have a long stretch where you don't have something and a AP goes down, you need to be able to swap it out. So whether it's, on curb stuff, it's good to have like a pre-provision spare, because Cisco licensing to transfer that stuff around, or fluid mesh. That can be kind of a pain to pull it. If the radio bricks because it gets struck by lightning or something, you have to log into that radio to release that license in the older setup to move it around, and then create an activation code in a web portal and move it around. So you, just like the physical hardware, having like a spare license in your pool and saying, okay, I've got 2 vehicle spares that can pretty much go in, and I've got 2 infrastructure spares that can go in, extra IP, so it can just get slapped in, and then next shift change or whatever, somebody can come in and clean it up and say, okay, this is in your sheet, this is now this access point, update your documentation, get that other one ready for RMA. Because sometimes, like, if you don't have that and you have to get that license free and clear, and then you have to configure that thing from scratch, and it's like, heaven forbid you're a controls engineer at a site that has no idea how to set up a DHCP server off the rip to log into a radio or something like that. And then where do you get the firmware? What happens if it locks up and, something happens funky with the firmware going in, stuff like that. Sometimes this stuff can be testy out of the box. So avoiding that stuff.
This brings up also an interesting point, that there's a big fundamental difference between most industrial radios and enterprise radios, because most industrial radios are not controller based. You have to log in to each individual radio and configure them a very specific way. You don't have a controller to where you can download your where everything automatically downloads. It picks up your SSID profiles, it picks up your RF profiles, and then you're good to go. You're not running RRM, you're not running controller-based security profiles. Everything is individually configured. Now, you might have software that helps you map it all out and gives you a point and click, so you're not having to type in an IP address every time. But when it comes down to it, you're connecting to and logging in each individual radio and configuring them how they need to be. So that can be time consuming as well.
And that's back to one of the very first things that I said is, like, when you're engaging with a customer on one of these projects, give me a not 200 meg CAD file so I can open it on my, like, not 128 gig of RAM CAD machine that I don't have. But it's like, give me some drawings, give me some ideas, give me some information about places that we can go. And then it's like it's like you can lead the horse to water, but you can't make it drink kind of situation. Sometimes customers take the recommendation, and sometimes they don't. And it's, it may not bite you in the butt. You may have radios in paper, right? I went to help cut a site back on that was running, and they had some switches in there that were end of life in like 2008. And this was like 2 or 3 years ago. End of life in 2008, still running like a champ.
You have just described 70% of the world of pulp and paper.
Yeah. And then it's like, welcome to the sinus infection you're going to get walking around in here from the air. But I mean, there's it's some of this stuff just persists. I mean, it just runs. We had, what are those things, like the Slick Fives, it's like the older Rockwell, is it like Rockwell or Allen Bradley PLCs?
PLC 5s?
Yeah, PLC 5. Yeah. We had a traveling carnival kind of thing that had one of their rides run through the, like the little, like, not, the
all the ones that look incredibly safe.
Yeah. And they had like dual PLC 5s on there, and like one of them was not working and the other one crapped out, and so we had to like configure one and mail it to them. So it's like that stuff that stuff's like still running and stuff. But that's, I mean, too, like, that's a lot of kind of what we do too, is we get sucked into that kind of stuff because we do DCS for all kinds of applications and RFID and software and environmental reporting and all that kind of stuff. So it's like sometimes you get pulled into this stuff, and you're like
Prism GPA, we're full systems integrator. So we have the process control guys, we have our infrastructure guys, we have our MI guys. So it seems like Prism's kind of structured the same way.
And occasionally you have to be the expert that's like only physically touched the technology, like one of the devices one time, but you have to figure it out when you're on site. And that's kind of too, in the OT world, like this is like one of my favorite quotes from Dune, but it's like basically like survival is the ability to swim in strange water. And, it's like, you just have to be willing to look around and dig around a little bit. And I don't know if you've seen this, but how many times is there like something weird? You get a wireless problem and you're like, you get your machine out and start looking. And that's the thing too. Oh man, there's like so much popping up. The controls and OT people, it's like, hey man, there's there's stuff like the Wi-Fi Explorer Pro, which is now for Windows, so you can get it. But it's like WinFi, it's like, hey, get this here, man. Or like, hey, you got an iPhone, like open up the airport utility and scan this around and tell me if you see this, or like stuff like that. Just get some kind of idea. But hey, bye.
Absolutely. The amount of free tools that are out there that you can download to your mobile devices, just your mobile devices alone, to get a quick snapshot of what you can see as far as structured wireless is concerned. It's insane.
Yeah. And it's really like, I mean, it's amazing, like the tools that are developed, it's like pretty much every site I go to, like in some of the situations, I'm like, man, you could do this packet capture, like get you, spend a couple $100 and buy you one of these like WLAN pies and just sit it there, because it's like, if you have a problem, that's a whole nother beast. Like, how do you run packet capture in a machine cell that you can't go into, or how do you survey that? Like, man, that's a whole art in of itself, because it's like sometimes you just can't physically access a space, or like you're trying to set up a crane and you want to say, okay, you've got, right now you're running infrared or something, and you want to move to a different technology. And so it's like, you've seen that Frankenstein box that I built, but it's like, you got to build like a box with a battery, and then not necessarily like super sketchy, but then, Mr. Me that doesn't like heights has to put on a safety harness and go 100 feet up, and then, help strap this thing to a wall and then ride a crane to take measurements. That's the stuff where it's like, oh yeah. Oh man, let me definitely tell you this, because when we were talking about this like we're talking about ARC-coax, and
let me clarify one thing to all of our listeners. Both Jeremy and I are ADD is all get out. So if we start wandering, my apologies, but we'll get back on.
Okay. Yeah. There's so much stuff popping up. So another thing, if you're going into an OT space and you're an enterprise person, it's dangerous. It is incredibly dangerous. I was troubleshooting coax ride one time, and I'm up underneath this vehicle, and I didn't know fully what, like 480 was.
Oh, ouch.
And well, I didn't get hit, but it's like, you're kind of like poking around up there, and then somebody notices and they're like, oh, hey, this like power rail right here will kill you if you touch it. And so it's like, just being at the escort you have on site is like your best friend. It may be inconvenient, but you should never be upset that somebody's trying to keep you safe on site.
Yeah. Site safety training, the appropriate PPE, that's all incredibly important, especially in the world of pulp. I reference pulp and paper because we do so much in pulp and paper.
Mm-hmm.
And what people don't realize is all the different processes that go into pulp and paper. So not only do you have your wood yard that's making chips to turn into paper, but you have chemical plants on site, you have wastewater treatment on site, you have power generation on site. So you essentially have 3 or 4 different miniature manufacturing plants all working together to create one end product. So the safety training that you have to go through in order to be able to operate in any one of these areas is fairly extensive, and it's very, very important. And there's a lot of cabinets that we go to that we are not allowed to touch, that we have to have the appropriate personnel on site open for us so we can just take a look because of that 480 power.
Yep. Arc flash protection. I mean, that actually just came up where it's like, even like down to 110, it's like in some places you can't open a 110 cabinet without arc flash protection. And I mean, sometimes you open cabinets and they are not well manicured. But I mean, even stuff like, there's ARC-coax installations where they put it near, it's a convenient place to put it near the bus bar where you're getting that power. And there's specs for that. I was at an auto manufacturer, and, the coax was installed properly, well, semi-properly, but it was insulated. It's not touching anything. But they put it too close to the bus bar, and it's not a vehicle, but it's, the carrier that would carry the product that was being painted would get its power from the bus bar via induction. And so I went to unscrew the antenna cable from the radio, and then all of a sudden that's not grounded. And I got 110 volts off of a fully isolated in the air antenna. It's like sticking a fork power socket. So it's like stuff like that where you're just like, you just like really got to watch where you're touching stuff when you go places. And do your due diligence inspecting stuff before you get to it. And it's, something like that, like you wouldn't, I've touched 100 pieces of our coax, and that's the only time that's ever happened. But
Yeah, you won't find that in enterprise.
yeah, but be aware of that. I mean, we, don't want to tell any tales of out of school, but we did a project in the subway and tell you, like, don't stand on these wooden protectors over the over that rail that's there to keep dust off the power rail that the shoes contact. And the maintenance guys, they're around that stuff all the time, so they're just like standing on it, sitting on it, and then they'll also tell you that, like, the last person that got hurt fell off of off of one of the train cars onto the tracks, like an employee wise, and they touched it. They were holding something, they touched it, and basically, like, it blew their arm off. Luckily they survived, but it, like, blew their arm off, and you're just, here these guys are just like bouncing around like it's a springboard.
Oh my goodness. Well, we have covered a lot of material in multiple directions. And I got to say, I've learned a lot myself. I appreciate you coming on, and I really want to thank you for taking the time to come and hang out with me and to talk mobility and safety in industrial and manufacturing and entertainment. That's some interesting stuff. So hopefully I can get you to come back at some point and we'll talk some more.
Yeah, I'd be happy to do that.
Well, I'll drop your contact information, both you and for your employer, in the show notes, and we'll link up the Kelly Slater wave pool video as well.
Yeah, I'll send you a couple of out there projects that you could, if anybody's curious, and there's stuff linked on the site. But yeah, that one's like a pretty fun one, even though I can't ride it. I probably couldn't even stand up on a surfboard.
No, my balance is terrible, so I'm not even going to risk it. I'd break something. I'm 50. I'm going to hurt.
Yeah, I'm more of a barge than a speedboat.
I'm with you on that, my friend. Well, thanks everybody for tuning back in for the second episode of the Industrial Wi-Fi Shop. I hope you'll come around for the next one. Thanks for listening, everybody, and we hope you join us on our next episode of the Industrial Wi-Fi Shop.